Hello, sir. Am I audible? Hello.
Good morning, Dimri.
Namaste, sir. How are you, sir?
Fine, thank you. Thank you very much for agreeing for this talk.
Thank you for giving me this opportunity, sir.
Thank you, Dimri Saab.
Yeah, namaste. Thank you.
Thank you.
Good morning, sir.
Good morning. Can I send you my PowerPoint or which you can load for me in case of their glitches?
Yeah, I think that is better.
Yeah, because I find many times because of the different machine, there are glitches. So I would request.
Yeah. I think IMD in New Delhi who
Yes.
are coordinating the WebEx, so they can share the.
Okay. So I'll send to the same mail, sir, where
I don't know from which email you got the invitation.
I got it from Indian Meteorological Society, Imsociety@gmail.com.
Yeah, I think you can send it to that.
Yeah.
Sir, good morning. Sir, good morning, sir.
Good morning, Giri.
Is
Dr.
it
Professor
audible,
Dimri
sir?
wants to send the presentation by email. So he will be sending to Imsimd Society email.
Okay, sir.
So in case there is a problem for him sharing, so please ask your colleagues to share from
Okay,
IMD.
sir. Okay, sir.
I have already sent.
Okay, sir. Okay. IMS.
Yeah.
Okay,
Yeah,
sir.
IMS. Yeah. Thank you.
Yes. Sir, sir. Okay, sir.
So you can roll it for me.
Yeah, yes, sir. Yes, sir.
At times it. So we have time to fix it. So got it, Dr. Giri?
Sir.
You got my email, right?
Yes, sir. Just I'm checking, sir. One minute, sir. Checking, sir.
Yeah. So Rupas Kumar sir, you are in Pune, right?
Yeah, I'm in Pune, so you can come this side. You are very close now.
Yeah, I will come, sir. It's very close by.
Yeah. So how is your new responsibilities?
Yes, sir. It's a good learning lesson for me. More scientific interactions at different dimensions than only meteorology, and simultaneously more responsibility in the context of capacity building and finance and administration. So there is a So generally this talk is for 45 minutes, I assume.
Yeah.
I made it like 45 minutes, and then if there are some question answers.
Yeah.
इधर ही रखो।
सर मैडम पहुंच गई घर पे।
पहुंच गई, घर पहुंच गई, सारा सामान पहुंच गया। इस नीला मैडम बताएं ना, ठीक है। मुझे अभी डिस्टर्ब मत करना एक घंटा।
Giri, are we ready?
Sir, yes, sir. Abhi just 2-3 minutes, sir.
गिरी साहब वो पीपीटी अटैच करने में दिक्कत होता है, इसलिए मैंने आपको
जी सर,
पीडीएफ भेजा है।
जी जी।
हाँ, वो आपको फिर दिक्कत
सर, वो
करेगा।
पीपीटी भेज सकते
पीपीटी
हैं?
भेज रहा हूँ अभी, मैंने अभी pd.pdf भेजा है, विच इज इजी।
ओके सर।
पीपीटी क्या होता है, बहुत सारी फिगर्स होती
हाँ,
तो
yes,
वो
sir.
अपलोड नहीं होता है, तो अगर
Yes.
आप .pdf को ही रोल कर दीजिए।
ठीक है सर, एक बार
हाँ, वैसे मैंने पीपीटी भी भेज
मिल
दिया।
तो गया सर पीडीएफ, अभी वो सर ट्राई कर रहे हैं इधर से शेयर करने का।
मैंने पीपीटी भी भेज दिया आपको।
ओके सर, ओके।
Good morning, Dasha.
Hi, good morning, Dr. Kohli.
गुड मॉर्निंग
How
सर।
are you?
Yeah, you're audible.
Last time I could not attend. I was busy in a different place.
Yeah, I think you informed us about that.
Yeah.
Giri, you can initiate whenever you are ready.
यस सर, यस सर, यस।
Good morning, sir.
Hi, good morning.
Good morning, Anand.
Good morning to all. Yeah, namaste.
Please, sir. Good morning.
Namaste.
सर आपका पावर पॉइंट यहाँ से मैं से शेयर करूँ क्या?
Yeah, that's what I requested.
ओके ओके,
Because at
मैं
times
शेयर
there
कर
are
लेता हूँ।
glitches, so I requested IMS office.
या
in
ठीक है।
communication with Dr. Giri. Maybe if you can help.
चलिए, हमेशा ये प्रॉब्लम होता है।
Yeah, so yeah, I always prefer to send in advance. So though I can go for an hour without seeing slides on Himalaya at least. So please tell me when to start, and I'll start communicating my talk without wasting much time. Already it's 11:05, so. हाँ, नहीं वो घर पहुंच गई हैं यहाँ पे। मैं बाद में बात करता हूँ तुमसे। चिया से बात कर लो। हाँ। ट्रेन से आई हैं। ओके, ठीक है।
मैम मध्य महाराष्ट्र वाइड स्प्रेड।
Sir, is it visible now?
Yes, yes, to me, yes.
Okay.
To me, yes.
There is some dialog box in the front about rearrange videos in this stage, something like that. You can get rid of it.
Sir, it is at your side, sir. You close it.
Oh, I see.
Yeah, it's individual sites. Yeah.
Okay. Okay.
Good morning, sir. Good morning, everybody.
Yeah, good morning.
Sir, can we start, sir?
Yeah, I'm ready. Yes, please.
Yeah, go ahead.
I'll request Professor Rupakumar to
Yes,
grant
sir.
me some-
Patnaik will initiate. So,
Yeah.
Okay, sir. Okay, sir.
Okay, so welcome to the IMS lecture 5th in series. Actually, it was discontinued for some time, but now we are coming again with this the series. And the first talk in this in second phase, in fact, I can say, Professor A.P. Dimri, and actually he didn't need much introduction, but yes, we are closely working with him, so I know I'll speak something about him. Actually, he started. He was working for a long time in SASE, the Snow and Avalanche Center in Chandigarh, and after that he joined JNU Environmental Science, and he worked there for quite long time. There he basically on the West Himalayan climate and winter weather, that is his focus area. So many years he has published many papers and also guided many PhD students. He is an academician also, and recently he has also got another assignment in the director of that is in Mumbai, Dr. Dimri, yeah, that is in the geomagnetism, right?
Yeah.
So yes, at present he there, and he is very good academician, and people will be interested to listen to your deep knowledge on this area. And without wasting much time, I'll request you to kindly deliver your expertise and give a valuable talk. Thank you. Over to you.
Thank you, Dr. Patnaik. I hope I'm audible to all. Professor Rupakumar, IMS, my teachers, colleagues, dear friends, thank you. I'm very happy that IMS gave me this opportunity to share whatever the knowledge I have over the Himalayan research from past 3.5 decades. And I have made an overview talk, so I might be not suffering touching many dimensions of Himalaya. Himalaya is a natural laboratory. Many of us try to create a thematic laboratories in a system. Himalaya itself is a very beautiful, massive, protruding out of the earth because of plate tectonics, right? And when two plates collided 55 million years back, the Himalayan orogeny started coming in geomorphological sense, right? Which has a very many manifestations on our weather and climate. So by virtue of that 55 million years ago, two plates came into continent, and their collision was not as linear, or rather it was a very, very smooth and geological sense. And roughly the Indian Summer Monsoon, which we weather and climate researchers, we talk of, it started 15 million years ago, and the recent paleo studies say Indian Summer Monsoon or monsoon started 22 million years before, because of this is Himalaya stopped northward propagating currents, and hence the monsoon started. And another beautiful thing happens: the foothills of Himalayas is not the tectonic mountain. I hope most of the people might be knowing it. When the monsoon started coming, hitting the Himalaya, the physical erosion was the sedimentations, and the Shivalik is the sediment mountain. It's not the tectonic mountain, and there are many very fault in between. Ranges came in a cascading manner. As I said, it was not very smooth as far as this is concerned of the Himalayan orogeny is concerned, and hence I will not go in much tectonic evolution of the Himalaya. There are other people who can talk on the geological earth science, but this preamble I was fixing to understand that how monsoon has started, how the various currents have started, how the protrusion of Himalaya is influencing the global current also. That's many other people have talked about. So for our context of climate and weather, in particular, Himalaya acts as a water tower. Next slide, please, Giriji. Himalaya acts as a water tower because it has a very many water retention, terrestrial water within the surface, cryosphere, glacier. Now we are researching on the permafrost also. So that's where we have seen that it's a water tower of Asia, many people have called. It sustained the surrounding 8 nations. The 8 nations river surrounding this Himalaya is sustaining the downstream population, it has a very unique and heterogeneous variable topography, heterogeneous land use, land cover. This mix gives a very different kind of natural and varied man-made processes lead to the ecosystem. There are many researches has been done over the Himalaya. I'm limiting only to report few of them in the climatic sense, that winter warming is reported by many people. Elevation dependent warming has been reported by very people. That's not homogeneous elevation dependent warming. And precipitation patterns are very complex because of the regional responses. Some of these I will get into when I'll talk on the regional responses subsequently in few of my talk. And this led to a very different kind of understanding when we are talking of Himalaya. Some of the work which you might have seen in my interactions or my earlier talks, few of my work. And then a lot of work has been done on the Hindu Kush Himalayan region with this recent understanding. Next slide, please. Recent understanding, evolving understanding. People are working with the modeling framework, different modeling framework, and then reporting over the region, how this mountainous region in particular is behaving. We have to understand this is a data gap region. We have to understand most of the researches are done based on model resources, and then hence the available information over the Himalayan region is quite scattered as far as it was there 3 decades back. And with the continuous study, it has to be underlined need of multidisciplinary research. And let me also tell you, so far we have not talked of the geopolitics, which is another important aspect people are trying to look at over this region. And with that, this mountain focus is upcoming in various repeated IPCC working group debate, and in plenary approves process will begin in 14 February 2022. Next slide, please. And that's what high Himalaya looks like. I'm only picking up out of the Himalaya. I'm carving of the Indian Himalayan region. That is this southern flank of the Himalaya. That's what is the topographical variability. If you look at it itself, we have a very limited kind of observation over this network, and most of the network from our side is limited to 3,000 meters, not beyond that, as far as I know a few of the stations. And apart from the spatial heterogeneity of distribution of the network observation, Northeast is better monitored, and as compared to the Western and Central Himalayan region. In recent decades, in recent years, the observatory network has increased, satellite radar information has increased, and that's what brings to the next slide, please. Himalayan regions context of the swath observations are missing. Next, please. So there are a lot of climate uncertainties. Next, please. So a lot of climate uncertainties. If you look at this preview graph of the blue color, I have just taken the aggregated data for the best available sources. They look alike. It's a good thing that all three, Aphrodite, GPCC, crew, IMD data I could not take here because IMD doesn't have this Himalayan region which falls beyond the national boundary. So I'm going ahead with this discourse in particular climatic sense. So all three look spatial pattern bit different if you look very carefully. There could be a climatological uncertainty in the theory of the development of method. Certain kind of statistical forcing is forced over these methods, and hence for a larger pattern they look similar. There is a elevation dependent flow is seen, and particularly when you look at the altitudinal uncertainty, this is scatter plot here, we see that the variability where the interactions of the precipitation at the lower elevation is there, your variability of precipitation intensity is very high. And as you go to the higher elevations, you have a almost clustered precipitation intensity. But in the middle Himalayas, we have not very defined kind of pattern. And that's what is a very tricky, which also we try to look at this, that how this happens at roughly 3,500 meters elevation, what is the problem? And beyond that, if the precipitation moisture forced up by certain mechanism, forcing slip there, variability is limited. But where the orographic process begin at the lowermost Himalayan region, that's what is the different physics is there. And if you look at the trend of precipitation last 30 years, we find that at higher Himalaya, at the 3,500 and beyond, where precipitation is increasing comparatively, and lower Himalaya, it's a negative trend is being seen if you look at the vertical blue line. Next slide, please. In case of temperature, if you look at that, higher Himalayas, of course, are colder because of elevation. And if you look at these 4 seasons, winter, pre-monsoon, monsoon, and post-monsoon, and different sources of precipitation, temperature from different ANSEP, CRU, Afrotemp, all these available 5 data I have chosen here. We find that all 5 have very different kind of precipitation temperature values. It is synthetic data is being generated by available data from the point in situ data, and hence there is likely of the forcings within the generation of that. And this particularly vertical elevation which you see, of course, this is a lapse rate. People talk of the lapse rate, but let me tell you, in Himalayan region, the atmospheric vertical lapse rate doesn't work, which is 6.4 or 4.5 or 9.6 degrees centigrade dry diabetic. So I'm not going on that debate. We found that we have a slope environmental lapse rate when there's an interaction of the valley floor and valley walls to the decreased temperature. So in case of the Himalayan region, we have to be very careful with this. So these are the some touch upon I have done with the observations what we use in general for the Himalayan region. Of course, these are more better when we are coming to down plain region of Indian subcontinent, because we have more number of in situ observation. We have a horizontal plains. We don't have a complexity of the vertical topography as is seen over the Himalayan region. So over the generally Himalayan region, we have certain kind of problem within the observations available there itself. I understand this is terrain topography is like that. Next slide, please. And then with that, we have taken the CORDEX-South Asian domain. Now we are using CORDEX core. My work is already under consideration, but here I am showing limited to my work to the CORDEX assay experiment over these regions, how this CORDEX assay experiment look alike over the region. I am not going in the CORDEX assay experiment in detail because it is known. Data is picked up from IITM, and I will not go much in detail. Next, please. And in that case, we found that in the mean annual cycle of the member, CORDEX member, which we have chosen available at that time. Next slide, Giriji. We saw that all the members, when we compare with the corresponding observation in mean annual cycle, we find that most of the models, there is a problem shuffling the slide, right? Can you hear me?
Yes, sir. Yes, sir.
So yeah, now it's okay. Yeah, now it's okay. So if you look at the graph which we are showing in the left, we see that the average line graph, we said sometime the model is showing precipitation much ahead of the actual observed. I'm not going in the observational problem anymore. I'm just assuming that my observation, which I have shown with uncertainty, I'm comparing with that only. And with that, which we find that some of the model are exactly not behaving. However, few of the model are exactly reproducing the mean annual cycle of the bias in the precipitation. And when you look at the spatial distribution, it's a very, when we compare and when we, this I am showing the bias plot here, we find over the northeast region and where over the foothill of Himalayan region, you have a dry bias along the foothill, whereas when you go higher up, model starts becoming more wet as compared to this. And ensemble, when we do the model for better representation, we find that still lower elevations or foothill of Himalayas, where initial interaction of the summer monsoon flow comes into the picture, it has a dry bias. But as this picks up and starts going up in the higher Himalayas, I'm not going in the vorticity and the physical processes of uplifting the orographic forcing up there, we find that upper Himalaya is more wet. This is the last 30 years data I'm representing climatic average. Next slide, please. And when we compare with the blue graph, and of course, this temporal distribution of JJS mean is not very well matched, but yes, ensemble, when we are making it, we find that through the period of consideration, ensemble is coming a bit closer because of averaging out, of course. And when we see the altitudinal distribution, in particular JJS mean, the at least the upper elevation region where the wet bias is there, we find that the variability of model is correspondingly captured well, what we see in the observation. But still, when we are in the lower elevation, the models are doing very differently, And of course, in the ensemble, it comes a bit closer. But middle Himalaya, again, 3,500 elevation, again, is not very well matched over the region. Next slide, please. We did various statistical analysis, and based on the statistical analysis and very number crunching, we found that one of the model which suits best within the India meteorological, within the Aphrodite temperature precipitation, we have chosen that, and based on that, we further went ahead. Next slide, please. And based on that, what we have seen that one of the model is best, and rest of the analysis I am providing only of this particular model, in particular to look at the mean and extremes and so on and so forth. Based on that, we find that how the mean characteristics of the winter and summer in particular, it looks like over the region of Himalayas, which I have shown in the beginning. Next slide, please. And various statistical correlation temperature has been shown, and this is scatter plot. If you look at, like, for comparison with the observation and model, so lower intensity events are captured, but when we go to the higher intensity events, roughly 220 to 200 millimeter events, they are scattered out, so they are not even captured in any of the models. So maybe these model are unable to capture high precipitation event, because what we have seen in this model physics in particular, there's a horizontal mass exchange is not allowed, only the vertical grid mass exchange is allowed, and that is one of the key issue in the dynamical model, which cannot capture very high intensity events like cloud burst or something very high intensity events. That's a big problem. And in particularly now we are talking of extremes and all those events. So getting the bullseye kind of precipitation distribution within these physical dynamical model is kind of difficult to capture in this sense. Though I am talking over the region Himalaya, where the convection is comparatively less than the Indian subcontinent, but that is one of the reason over this, and so many uncertainty we have seen over the region, right? Next slide, please. And then based on this, next we look at the temperature biases, because temperature and precipitation are two key figures when we are talking of the slope environmental lapse rate, when we are talking of the glacier dynamics, when we want to talk of the hydrological modeling in a glaciological hydrological sense over these regions. That's the two basic parameters which are need to be very importantly understood. I will not talk today bias correction, or I will not talk today how these data we have used for the snow hydrological purposes. So there are various bias correction methods based on which from the whatever available in situ data we have over the region, we have corrected it. But the only problem of the bias correction of the temperature and precipitation data is that we have to take it the sub-regional scale, because only we have a clustered of in situ data taken at the sub-region in experimental mode by various groups, various research groups, from where we have taken localized data of the corresponding time, corresponding spatial evolution of the sub-regional or sub-regions over the Himalayan region. So temperature also have a problem. Now the issue is for what purpose we are going to use, that should be very careful. Otherwise it is very elusive for a very specific purpose. I also understand the philosophy of regional climate models. They are not meant for hydrological purpose. They are generally meant for the regional climate forcing purposes. Yes, but still, if we are trying to look at the filling the gap area of observation through model, at least certain benchmark can be taken into account. Next slide, please. And in view of that, most of the models are cold bias, but it has all of them have a distinctly similar pattern of the observation, corresponding observations from graded reanalysis. So in a way, it is good to understand that our model are behaving in a similar kind of dynamics, though in a colder manner. And that is one of the reason, if you remember the precipitation slide where we are getting conflict. So temperature is one of the key parameter for initiating the energetics within the model physics to have a precipitation forming processes when we are talking about these regions. So these are the few. Next, please. And then it also depends on what study we want to do, this uncertainty and biases. If you look this normal bell-shaped graph, we find sometime their mean is matching, but their spread is not matching. If sometime spread is matching, their mean is not matching. So it depends what we are looking at. Are we looking at for kind of their mean value dynamics over the Himalayan region, or are we looking for the cloud burst event? So it depends what kind of plus minus 3 sigma or mu what we are trying to look at. So next I'll move to the climatic change in the future. Next, please. And then I'll pick up certain very critical issues recently debated at next, please. Debated over these regions. We'll talk on that. So first, left and upper side graph where you see green and brown color, that's the future projection we have taken after knowing how good and bad our model is in the present. And this is for the near future, where we are finding that the eastern side of northeast side of Himalaya, as per the model details, are going to be drying up, whereas the central and western side of the Himalayas will be going to be a much more precipitation likely in the future. That is the percentage change we are talking on near future, that is 2020 to 2049. So this is 30 years average. We saw that, and dipolar pattern of the eastern Himalaya have a reduced precipitation. But as again, I want to repeat, we have certain uncertainty with the models, and in particular observations over the Himalaya that remain a challenge to compare these model with the output of the precipitation. However, this will provide a kind of benchmark study in the future. Even if we don't have anything, at least certain information is available with certain error, because we know how much error models have with the present data. And with the evolution of science, it's likely that more kind of questions and this thing will arrive. And when we look at the 21st century projection from 8 member RCMs in the RCP 8.5, increased precipitation is likely associated, and the variability is also increasing. And in particular, when we talk of the elevation dependent changes in their trend, so we saw that lower elevation in different RCP, we have taken 3 RCP, 2.5, 4.5 and 8.5, and we have run for the winter and summer. So in both the case, we saw that features in the far future and near future, we find that at lower elevation, of course, in the RCP 8.5, the variability is increasing, but at the higher elevation, you have a less amount of variability seen over this region as far as the precipitation is concerned. Next slide, when we see the seasonal mean temperature, I think we all know IPCC has debated it long, and all of us, even the IITM also has done with these figures, where they have shown that there is a increase in temperature under all the seasons. However, if you look at the seasonality, we find that in particularly post-monsoon, October-November season and winter season is rapidly increased temperature, and higher elevations also are getting warmer. When I say warmer in that sense, it's not that I'm talking the higher elevation is warming more than the lower elevation. I'm talking of the warming rate is more over the higher elevation than the lower elevation. And if it shows that there will be a vertical atmospheric instability will be created because warming rate at the higher elevation is more. Next slide, please. And then we have different long-term trend. We have taken it out from mean near surface temperature from ensemble of these CORDEX assay, and similarly we are now looking for the CORDEX score experiment also, that how fine we can go, and what could be the role for the social impacts when we are talking for that. In next slide, as I was telling, that elevation dependent warming mechanism, of course this mechanism, next please, is based on the model data only. So it can be taken as a hypothesis because there is no observation is available. However, we have verified these with certain available data from various observational analysis. Based on that, as I was telling, that why 3500 meter is a very critical threshold over the Himalayan region. In particular, we found that above 3500 meters and below 3500 meter, atmospheric physical processes behave entirely different, and then we find that amplified warming over 3000 meter is more during winter in particular. And because in 3500 or 3000 meters, that band, we found there is a kind of conditions which behave in certain manner, which leads to the more cloud forming mechanism process, not rain, clouding. So this clouding over the Himalayan region in particular, when we have taken a different grid scale analysis and simultaneously corresponding the total cloud fraction and downward long wave radiation, we found that this kind of a situation leads over the Himalaya region, where the increased DLR at higher elevation could be due to the coupled feedback mechanism of moisture and the cloud cover increase. That is the reason 35,000 threshold is very critical above and below the Himalayan region. Next slide, please. And of late, we have come to the Karakoram anomaly, when we saw that how the glacier is increasing or they are stable. If they're increasing, definitely there has to be mass added on it. Otherwise, glacier in itself cannot increase. We chose two of the important regions of the Ladakh and Karakoram. They are very adjacent region to each other. If you look at the figure A, we cut these two regions and tried to look at, with the available data from APROTEM, why this could be a physical process. Again, over the reason that if we can think of why this Karakoram anomaly is like that, it's not behaving like other glaciers over the Tibetan region or the Vatula, Karakoram, Siachen. What could be the reason of they are going? So based on that, next please, we did various analysis, and they have reported by various researchers. Next slide, can you show Dr. Giri, please? So many researchers have reported that the Karakoram glacier mass balance is positive. Of course, as I said, that heterogeneity is there even at the very regional scale. As I told, I'll move to the regional scale also, and the all regional scale have different kind of climate, different kind of weathers, different kind of forcings, and most of the elevation ranges in the cold arid region. That's what is Ladakh, we call it. Less amount of precipitation happens there, and it's a cold region. And simultaneously, we have adjacent Karakoram, which is higher, and lower ranges of Karakoram colder than the corresponding Ladakh region, Leh region. And then what could be the reason? When we know the geomorphology, when we understand the general climate over these two adjacent regions, then we try to prove what Karakoram anomaly could be. That is the way we moved ahead and did various analysis. Next, please. Based on this, we have looked at the aridity, actually what happens that, because we found that the aridity pattern affirms the Karakoram anomaly. When we look at the decadal trend of aridity index, it shows that very interesting rationale for affirmation of Karakoram anomaly, that categorically increasing trend of aridity index over the Karakoram, not the cold arid region, comparatively is decreasing. So our cold arid region of Ladakh, Leh, is getting more drier because of the increased temperature. We did temperature analysis also, but in case of Karakoram, we find that aridity index is kind of there is more aridity is coming. So this shows that in these decades, Karakoram is having more moisture coming over, transformed into the region, and when it's more moisture is transferred over the region, it is getting mass gain over this region, apart from certain climate change issues, and discussed that also in the next slide. Next slide, please. And if you look at the monsoon season and winter season, the lifting condensation level is another factor where the cloud base comes over this region. We also saw that the cloud LCL determines that how much of moisture is getting dumped over the region. In view of that, LCL trends during summer show that lowering over the Karakoram than the low clouded region. And that is one of the case that LCL is kind of sitting on top of the Karakoram elevations. So because of elevation of the Karakoram, it's kind of whatever moisture a little bit is coming by any source. I'm not going as of now, it's summer monsoon or winter monsoon dynamics, though we have taken two seasons, but I'm not talking of that as of now. But we found that this moisture kind of monsoonal moisture thus inhibits swarming also, because the clouding is there. So it is a kind of feedback mechanism is happening. You have a little bit moisture is coming over there. It is creating the monsoonal cloud, and by virtue of the monsoonal cloud, warming is inhibited comparatively the Ladakh region. And again, this is a hypothesis is provide that summer type cooling in present scenario over the Western Himalayan anomaly explained in the next slide, please. If you look at the trends of 30 years, figure A, over the Karakoram and over the Ladakh region, specifically over the region, we have tried to provide a feedback that skin temperature is decreasing over the Karakoram as compared to the Ladakh or rest of the Himalaya, and that trend shows that there is a kind of a surface snowfall amount is increasing because melting is not happening in that context, and by virtue of that short wave radiation and long wave radiation is kind of making it conducive physically that Karakoram anomaly is, that's the affirmation explained in the model as well as the snow albedo feedback mechanism. With observations, maybe more physics can be done. Model has its own limitation, but without observation, certain kind of signatures are captured as far as the physics is concerned over this region, and hence there is an increased surface snow amount leading to decreased temperature and increased albedo, and so energy is less retained over this Karakoram mass. So that is one of the thought we have provided in here over the Karakoram region. Now I'm slicing the Himalaya to the smaller region to have a better sub-regional analysis. So next slide, please. We saw that over Indus River Basin, we have monitoring this Indus Basin from some few years, and this is a very interesting research field, natural laboratory of Ladakh, as we saw that two adjacent region of Karakoram and Ladakh, they don't have a similar kind of climate and distribution, and of course based on limited observation and based of the model. Next please. We saw that unanimous increase in temperature. Next slide please. Unanimous increase in temperature is happening everywhere in different RCPs 8.5 and 2.6. These results are all from CORDEX, which has been done. Yes, there could be an uncertainty available in that. Dr. Giri, next slide please. So if you look at these different seasons, different models or ensemble, everywhere we find that warming is happening as reported by most of the work, that unanimous increase, and warming may be higher or lower in certain regions. Yes, that is reported. I'll not go in detail in because this is already being told by many people. Next please. In case of precipitation, when we are talking in general, next slide please. In case of precipitation, interestingly, we find the upper riparian of Indus Basin is likely to have increased precipitation trend projected over snow-fed higher elevation. Next slide, please. Yeah. If you look at the red color, these are the region of upper riparian region of this, and the trend is showing that there will be more amount of increased precipitation likely there over snow-fed, and rest of the basin is blue color is showing decline in the precipitation, and that is one of the reason that because of monsoonal dynamics or maybe SST temperature, your monsoon at least in paleo studies of tree ring, we have seen that monsoon is propagating a bit of northward and in the last 1,000 years time, and that's likely that monsoon precipitation is likely to be more in the upper riparian of the Indus Basin. That could be possibility here. However, spatial distribution doesn't have much say. But next slide, please. We will have very interesting that JJS season, monsoon season shows all around increasing trend, length, but comparatively and less intense over the post-monsoon or winter time. So that's what we have seen that upper riparian of Indus Basin will likely to have more water storage. This is water storage I'm showing. This is total precipitation minus evaporation and limited to only these two factors. I am not going in the complete terrestrial water source available in the over the region. So this is the way we interpreted that water storage is likely to be increased over this region. Next slide, please. And in case of Kashmir Valley, it is a very interesting feature. You know, earlier slide I was telling that lower elevation warming rate is less than the upper warming rate. When I come to this section of Himalaya, particularly the valley, we found it just reverse. Here, the lower elevation is comparatively not behaving as in the complete Himalaya. It's a reverse trend because this valley doesn't let the upper atmospheric to interact between the whatever is happening within the valley, because and another important point in this Kashmir Valley is that they burn a lot of bukharis in the winter and even summertime also, and hence the lower valley is warming much faster than the upper peripheral elevation of this valley. So warming rate in the lower elevation is more than the upper elevation, which is not the case in complete Himalaya. In particular, this subsection of the valley. Next, please. I'll not go in detail of the apple crop, walnut. There are many impacts on this is happening of the additioning of moving ahead of the plantation and all those crop and rice and also and so forth. So this valley, if you look at that, it's a very beautiful valley. And then based on this 30 years data, we have seen that a lower rate of increase in elevated mountainous region is found. Significant temperature rise we have seen over this region. And based on, next please, and based on the precipitation changes, they are all statistically significant, we have calculated, right? So they are not just simply trends are pushed into, they are statistically and precipitation is decreasing. Of course, precipitation is decreasing. When I say precipitation, it's very difficult to say snow, solid or liquid or mixed precipitation, because the capturing this is very difficult. But yes, there are research, there are reports where it has been published that there are less number of snowfall days are happening and more number of liquid precipitation is happening. It is likely that the temperature, precipitation and moisture play a very conjugate role in defining the mechanically and physically the precipitation forming mechanism. That is one of the reasons this is happening. Next slide, please. When we move to the Satluj River Basin, we find though temperature is increasing over this region, but precipitation is not having much change. And when we say like that, this is the cusp region in between where we have both amount of winter and summer monsoon arrive, and somewhere there is a kind of a quasi front of winter and summer monsoon, because glaciological people, they are of interest that we should be having where will be the kind of a precipitation reaching over this region. So Satluj is kind of a very in between where both the winter and summer monsoon arrives, right? Next slide, please. But when we go to the Ganges basin, when we slice, we find that upper Ganges has a different issues, and there is no much change in the future projections happening, neither temperature nor precipitation. We do not know why. Of course, the lower elevation, when we come at the lower elevation, the vegetation is also having a different problem, because the lower elevation is mostly rock and vegetation. But when we climb up at the Ganga basin, in the elevation wise, we have very clean ice, roughly 6.3% clean ice, which is changing slowly. So that still needs to be worked, that why this is not behaving like that. Next slide, please. So WD, I will not go in much scientific detail, but definitely one thing I want to say that Western Disturbances, IMD has done a lot of work. Recently, I have seen a paper also, very recent paper done by, I think, Srinagar group, Sonam Lotus is there. WD is mostly referred by most of the author from models. Nobody has seen from observational point of view. So model tricks that somebody says that Western disturbances are increasing, somebody says Western disturbances are decreasing, or intensity is increasing, or precipitation. So here just I am showing the corresponding precipitation with the Western disturbances, and we found that if you look at the red circles on the top, these are 2 bars, we found that Western disturbances precipitation, associated precipitation is one day precipitation in the recent 4-5 or a decade, if I say, in different December, January, February is decreasing, and non-WD precipitation is increasing. Now this is very critical. WD precipitation and non-WD precipitation, right? And statistical trend, if you look at the black circle and white circle in these 20 years data, these WD dates are strictly picked up from IMD's weather chart, right, from last 30 years, and we are analyzing that. This work is still in the process, right? We found that non-WD precipitation in recent decade have become more imperative over this region, and the structure of WD is also changing and decreasing the precipitation. And based on that, what we, next slide please, looked into the Indian winter monsoon. Well, some of the people don't agree with my this definition in Indian winter monsoon, and they say no, this is not a monsoon. But just to defend myself, they are the moist winds, right? Winter monsoon is coming like that. Reversal of wind, 200 hectopascal subtropical westerly jet is kind of reversing in the summer to the northward propagation, and then in winter it comes to, so there is a kind of a reversal of wind is happening, meridional reversal of wind, if I'm more specific, of a 200 hectopascal subtropical westerly jet is meridional wobbling, right? 850 hectopascal, if you look at the surface winds, they are becoming northeasterly. There is a kind of another reversal. If you want to talk of the thermal gradient, well, if you go to the Marginal formula of frontogenesis, we have a thermal gradient, otherwise fronts will not form, right? So warm front. So I'll not go in that detail of defining Indian winter monsoon. Here we find a very peculiar, when WD is present in first graph, we have a stronger kind of influx of moisture. But when we don't have WDs, even then there is a certain kind of flow is there. And that's what we found in our analysis of isotope analysis, what we have collected water for a whole season. We found that now WDs are rising on the elevation also because of the increased temperature. We are still working on the dynamics of it, because of this, and they have increasing higher up in the elevation and rising up to the last range, which is Karakoram range, right? And while doing that, they are picking the moisture when there is no WD from the Bay of Bengal also. Some moisture is coming. That's what is the isotope characteristic. I'm not isotope person, but those characteristics have shown that, the isotope analysis have shown that in case of non-WD time, in particular, a lot of amount of moisture, precipitation happens there. We have analyzed the precipitation of non-WD days also. We found that a lot of precipitation is coming from Bay of Bengal side, because there is a Indian winter monsoon flow. It still exists in the winter time. Next slide, please. This is just a briefly I'm telling you that the blue color is the winter time precipitation yield from western side, and in the summer time DGF, JGS is the red color time, and that's what we try to provide, that how far in a climatological sense the monsoon comes, winter monsoon and summer monsoon, and what is the front, in case if we are trying to look at that, which side of precipitation is coming over this region. Is it for winter? Of course, there is elevational changes are also there. Next slide, please. In case of extreme, in case of extreme, they are increasing. I am touching the only extremes briefly over the region, and we found that over the shaded region of Himalaya, we find that almost 1.6% increase in accidents probability of 200 millimeter per day is estimated. And let me tell you, none of the model which I have analyzed yet have shown that amount of precipitation, and that is one of the very key when we talk of the extreme precipitation in particular. Next slide, please. And that I'm repeating those two figures here, where the extreme precipitation of 20 millimeter per day is the maximum captured in those CORDEX set of models, right, which has not gone beyond. So here, next slide, please. We have done one analysis that based on one regional model of Cosmo, which has the capacity of horizontal mass flux exchange among the grids, which is not the case, in other models. And what we have taken one 13th September 2012 case, which has burst in central Himalayan region, and it has yielded enormous amount of precipitation, in particularly damaged many downstream. Another problem with cloudbursts is they happened in the very interior of the Himalayas, so nobody reports them unless they don't have a downstream impact. So that is the rainfall on the 30th millimeter is reported from the government agency management disaster, roughly 200 millimeter in one day. But when we looked at the model physics, if you look at these two graphs, and particularly lower right hand graph, we found that this exceeding precipitation is immediately happened within few minutes. And we did various experiments, and we found that within few minutes time, the precipitation exceeds, and it dumps a lot of amount of precipitation over the region, and that's what brings the flux more in the downstream side, and that is one of the key reasons of damage when we are talking from that point of view. Next, please. And in the spatial distribution from model-based maximum reflectivity, vertical distribution of reflectivity, and rainwater mixing various hydrometeors, when we look at that, we can see that this kind of analysis is basically fundamentally tells what are the signatures at particular time in the model physics in association to physics of the cloudburst. Next, please. And that's what it looks like, and various physics schemes which we have run: Ritke, Hymax, and explicit convective scheme. Explicit convective scheme is one which tells the bullseye, captures the bullseye, which is reported over the region, and it looks like the next slide, please. I'm not sure if you will be next. Yeah, next slide, please. So that's what it looks like, and here you can see how it is evolving. If slowly, if you look at that along the over the region. So this is a convectively triggered system in Himalaya. Cloudburst is convectively triggered, orographically locked. If any one of the factor is missing, cloudburst will not happen, right? It has to be triggered somewhere, and that instability gets locked in orography, and then orography allows it to go vertically up in that section. And maybe in the next cross section you will see that. Next slide, please. In next cross section you will see that how the cloudburst forcing can go up to the 14 kilometer in height. In general, if you listen my annual average proposition of going the flux up, it will be 3,000 meters in general average, climate average over the Himalayan region. But in case of cloudburst, you see the precipitation go beyond the cell goes up to the 14 kilometer height, and that's what is a lot of intense precipitation is associated if moisture is available. Next, please. Similarly, we did one exercise over Ladakh also. It was also a very devastating flood. In this case particularly, we could generate the cloudburst cell, but still working in Leh from last almost 3 decades, I am unable to understand from where this much moisture has come, because that's very important to understand. So I could not still, if you ask for cloudburst, you need a lot of amount of moisture. In Ukhimat case, I know it is picked up by Terry recently made Jheel, and that is the reason that 2000 meter and 3000 meter you have more amount of cloudburst happening in the Uttarakhand region, because you have immediately convection happens, you have a supply of moisture from the nearby Terry Dam Jheel. But in case of Ladakh in particular, we could not assess that what could be the reason of this this thing. Next, please. Oh, sorry, skip this also. Go to the next one. Yeah, next. Yeah. So next slide. Yeah, next. Yeah, I have already shown this, so you can go skip these slides. Go to the next one. And this is very important, in particularly over the Ladakh region. When we say, next slide, please. When we say that how the hydrometeorological comparison of mean daily discharge in the rivers corresponding to dam and so forth is needed. Next slide, please. So that's very important. And then based on our analysis from past many years, we also discuss with them that how the knowledge priorities of climate change and water in abundance basin should be. We discuss with various segment of the society at the regional scale. We have discussed with the various segment of the policy and planning, and that's what we have come to that provide them certain feedback mechanism. Next, please. So next, so with this we have understood something, we have not understood something, and with the physical processes we have to analyze these factors, particularly when we are trying to look at that. Apart from physics, what we all might be knowing, and with the changing climate weather patterns, now the issue is that how the societal translation of these research has to be done. I know a lot of impact and effort has been done by various ministries and institutions already are doing it. Already they are working on this context, and still we are growing to understand the scientific feedback and all. Next slide, please. However, the uncertainty reduction of the error and improvement of the observations are, I think, certain important feature in my kind of understanding over the region of Himalaya is needed. And that's what next, please. I thank you all for listening. I thank you for various people who have made me this achieve this thing. So with this I stop, Professor Kumar, and hand over to you. Thank you very much.
Thank you very much, Professor Dimri, for that excellent presentation. And in fact, you have touched upon so many varied aspects. I think it's very comprehensive, and I'm amazed at the depth and breadth of your knowledge and also experience. And I think while there are many challenges in working with the Himalayan weather and climate, I think we are beginning to make some headway. And with these results, I think that there are many new challenges that we have uncovered. So I have a couple of questions before we open the floor. As you know, the Himalayan region is of interest, not only for the people living in the Himalayas, but also in the regional perspective, because as you said, rightly said, it's the water tower. And also it is great importance even in the planetary scale circulation features. So given that, what I would like to see is the special aspect of the Himalayas is the cryospheric element. So we have seen lots of changes in the precipitation, both in the observed and also in the projected precipitation. What do you think are the constraints facing us in terms of representing the changes in terms of solid precipitation and the precipitation as a whole, both in the observations and also in the models? As you know, we have the WMO has this new project called Global Cryosphere Watch, and they always complain about lack of information on cryospheric element from the Himalayan region. So how do we deal with this representation of solid precipitation?
Solid precipitation in the southern flank of Indian Himalayas are not monitored except by SASE, sir. And then SASE data is logged for different purposes. And that too, now they have expanded till Northeast also. That is a good sign. From I think 3-4 years now, they have moved to Central Himalaya and Northeast Himalaya also. Another problem with that reason is the measurement of the solid precipitation is true. When we are going and in changes of precipitation change and global warming change, the snow line is going up and vegetation line is coming. We have seen that. We are working in another project. There was very less time. We have seen that oak is taking over pine. When this species is taking over pine, because of these changes, snow is going higher up. So oak is also moving up because oak is thriving on the water moisture than snow. So then if that happens, then the species will also change. So maybe there should be a certain kind of a campaign mode has to be taken into account, where we have to have at least approachable regions where snow measurement has to be taken. What we have done with the small national mission program on Himalayan studies, we have taken certain attempt for defining slope environmental lapse rate and snow versus liquid and solid versus liquid precipitation. That is a very, very important, sir. Without observation, models definitely are giving supporting signatures. Even the rigid analysis also giving. And another problem is then when we talk of Himalaya, we don't have a Nepal. And we have a national boundary, but how can I define Himalaya from a national boundary? And then because the flow of the fluxes or the large scale flow, that is the another reason I faced in my research when I started, sir. So these are the two. I hope I could comment on that, but definitely with you, with the Global Cryospheric Watch, it can be taken up with certain extent. Yes, sir.
Thank you, Professor Dimri. Actually, I agree with you that the national boundaries create a problem in dealing with Himalayan region. And in fact, to address that, there are initiatives now to set up a third pole regional climate center network in collaboration with all the countries involved. So that by working together, I think each of us will gain in terms of knowledge and social benefits. So now I open the floor for any further comments or questions.
This is R. Malaswamy, the Secretary of Indian Meteorological Society, Chennai chapter. First of all, I congratulate Dr. A.P. Dimri for giving an excellent presentation, educative to all of us. I have 3 small questions. Sir has said winter warming is pronounced. If so, what is the range of the increase of temperatures? Question number 2, is the glaciers melting increased alarmingly? The last question is, can we attribute the climate changes for all the cloudbursts effects? These are the questions. I appreciate the IMS and IMD for organizing this also. Thank you very much.
Thank you, Dr. Secretary, IMS chapter. Based on my analysis and based on others' analysis, in Himalayan, the rate of increase is not uniform all over the region. It is varying from 0.3 degrees centigrade per year to 0.7 degrees centigrade per year across Northeast based on last 30 to 40 years data. And there are different papers that at sub-regional scale. So that is in fact found absolutely it's happening like that, right? Number 2 question you asked, the cloud burst is increasing. Yes, because we have more amount of available energy. Yeah, more amount of available instability because of the increased global warming. So definitely we found in last 10 years time, in particular the elevation of 2000 meters, 1500 meters till 2500 meters along the belt of Himalaya, there are more cloudbursts reported. Cloudburst reported, why I'm telling, because the cloudburst dynamics is not known. We see that when it is reported happen inside, but when we mark down that map, we found most of the cloudbursts all across the southern flank of in the Indian Himalayan region is limited to 1500 to 2500 meters band. It doesn't go beyond, it doesn't go below, right? So definitely global warming impact is there. What was your third question? I'm forgetting, sorry.
No, how is the projection for the next decade?
No, I don't have that projection. Sorry, sir. Whatever
Okay.
I have shown you over the Himalayan region. I don't have any numbers, sir.
Okay.
You have 3 questions. I thought I have answered. Yes.
Yeah, thank you very much for your
Thank you, sir.
kind clarifications. Please go ahead.
Thank you. Indira wants to ask a question.
Yes, sir. Thank you. Sir, thank you for the nice talk, and it was very informative also. Actually, I want to point out that NCMRW first produced one data set, that is the reanalysis data set. For 40 years, it is from 1979 to 2020, and we are extending this service beyond 2020 by providing the operational data set also. And there are many studies from ICER, Mohali and all. They are reporting this is a very good data set for studying the climate change and climate monitoring over the Himalayan region. So I just want to ask you, could you get a chance to analyze this data?
No, I didn't analyze. I know this data. I very well know about this data, and CMRWF, I know is doing human services. The data came very recently, no? So whatever
Yeah, we released it in 2018.
So very recently. That's what I'm telling. 2018 means now 4 years after COVID. Yeah. Some new researcher will use it. Indra, I'm old man now. Whatever I have used at my time, but I'm good that you raised this point, because I find 2 people when I was working in Himalaya 30 years back, people used to laugh off. Where is the data? This is bad guy. Only 2 people helped me, Dr. Sikka and Dr. Radhan Narasimha. And I used to argue opposite. There is no data. That's why we have to do the research of Himalaya.
Actually, Dr. Rajagopal, he is also there. He was the PA of this project.
Yeah,
so
I know.
I think he can comment more on this.
Yeah, my students are using this data, and IMD graded reanalysis also we are using for a monsoon research. In Himalayan region only, my comment is that I am trying to generate a gridded data for Himalaya. Already I am trying with the available in situ observation, taking from Nepal, taking from Sikkim, Bhutan, and some part of like that. Like Aphrodite has done Himalayan research, like Yatagai has done, because she has taken all the data for Himalaya, so people are using for Himalayan region. IMD data, don't want to criticize. People should not. There will be DG IMD. They should not take it otherwise. We should take the understanding that when I am talking Himalaya, how can I leave Nepal in central Himalaya? So that is my problem actually. So that's what I take other set of data. It's not that I don't want to use it. In monsoon,
Maybe you can encourage your students to use this data.
I also hope that. Yes. Yes.
Thank you, sir.
Thank you. Thank you. Yeah.
Thank you. Actually, this is a very important point. I think we with so many types of data.
Hello.
Reanalysis.
नमस्ते रमेश जी बताओ. हाँ 2-1 मीटिंग से हो गया, अभी एक चल रहा है लेकिन ऑनलाइन मीटिंग है.
Hello, can you mute your microphone, please, if you are not? Okay. Thank you. So I think we have now the possibility of having merged data sets where we can combine the conventional satellite and also reanalysis data sets to prepare high resolution information for these kind of regions which have very limited observational networks.
Yeah.
I think those, any insight into the limitations of these data sets will be very helpful to work on their
particularly when I work using AI ML method to generate the graded data set over one small region of Himalaya, Central and Western Himalaya, using my own project analysis and using that, they definitely see that there is a improved reanalysis available for this, definitely. Particularly when we are considering only Himalaya. So we are using certain kind of vertical gradient discretization method also, because Himalaya you have a H elevation also. So that is very important when we are using the satellite information available in this, when we also use the land use, land cover, land flux influence in this data set. But still I cannot resolve the solid and liquid precipitation, sir. That's my weakness, I think. I could not yet. That's a problem when how elevation is becoming solid precipitation. So I'm considering the precipitation as a whole.
Can I ask a question?
Yes, sir. Please, sir.
Yeah, Professor Dimri.
Sir.
First thing is that what Indira said, I think you should publicize that data set which is available. That's a good thing. Other than that, I wanted actually to ask you, because
Rajgopalan sir, I am in IIG now.
I know, you are close by.
Only ionosphere. So even if I tell them, yeah, please, sir, please go ahead.
So what I wanted to ask you mentioned about winter WD and winter monsoon. But I think many people are not aware or so familiar with the role of Western disturbance in summer monsoon also. So what is your opinion on that? Because that also leads to a lot of rainfall and flooding in especially Northwest India.
Yeah, sir, we have done some experiment with the summer WD monsoon. And very recently, you have rightly picked up this, and freak WDs are coming down south. And 2013 Kedarnath event was typically of the this thing was then, and we have proved an hypothesis given by Pisarati and Mulwakar, pulsatory extension of monsoon in 1957 paper they have, where they have mentioned this, but they have not proved it. We have proved this, that how WD, what they have proposed in that pulsatory extension of monsoon, that how WD when it comes down, it sucks the monsoon northward and takes the monsoon northward in a regional scale flow. So WD freaking with the monsoon, and it's happening repeatedly more in recent decades, sir. You have rightly said, sir, in case of WD.
Okay, the recent floods of Pakistan also are contributed by that WD.
Yeah, one WD was there. Successor of WD has come, sir, in case of that, Pakistan flood. We are analyzing that, but yeah, its work is slow, sir, because I'm here.
Thank you.
Thank you, sir.
Thank you. Madhu from IITM has a question.
Yeah, thank you, sir. Am I audible?
Yes, Madhu.
Yeah.
Please go ahead.
Sir, Dimri, sir, it's a very nice talk. I learned a lot of things from your things, like a Karakoram and Ladakh. There is a aridity index is decreasing kind of. Just I'm interested about to understand that cloudburst events with radars. So you are telling in your observation, their afforded data is very good. So as far as the rain comparison is concerned, is it correct? Aphrodite.
Well, Aphrodite is a general rain distribution mechanism it gives, but it doesn't yield you the in situ observation which is on the cloudburst scale, right? Cloudburst scale is 100 meter per hour.
Within a 20 minutes time it will happen.
Yes, per hour. And in one of our work in cloudburst, we have requested that we should relook into the cloudburst definitions also. a small region, a small per millimeter per day. So if you have a diurnal observation, you cannot capture the cloudburst. Because
sir, you have given 4th August 2010 or some other event. What rain data you used? Very good rain data you have shown.
That is the local gauge network by Uttarakhand Disaster Management Relief, because that is a confluence of two rivers, Alaknanda and Mandakini.
Okay.
So they have one confluence data discharge point taken there. So
actually, we want to confirm that whatever the surface rains, because you rightly understood there is a very lack of data. Even cloudburst, something we want to do it from radar. I want to match with the surface rain.
I understand.
How to do it is because you are the right person to ask. That's why I'm asking.
So, well, we have to scratch like this only and keep working. And then while working, we get the ideas. The way in the Himalayan research, I continued fixing things.
Then I can contact you.
And Ladakh, actually, what Professor Rupa sir has said is very rightly. We have to take a campaign national mission program, at least in a smaller region, like I did for Ladakh, I did for Central Himalaya, and now I am planning third phase to the Northeast Himalayan region. So have a monitoring at least for I know it's a not institutional project, so we have a less amount of funding, but at least we can have 2-3 years continuous monitoring, and based on continuous monitoring we can have explained the physical processes at least. That's very important, which is missing otherwise in a Himalayan sub-regional scale narratives. So that is important. Larger narrative, yes, monsoon flow we know, western disturbance we know, but when you are talking of the eastern, central, western Himalayan region in particular, that in case of cloudburst, you see.
Yes.
After cloudburst, maybe I'll send you that, because we discussed in a couple of meetings. I'll send this cloudburst in recent decade, and somebody was asked, it's not going beyond 2500. These all cloudburst event reported. It's within the belt of 1500 and 2500. Why? I don't know. So maybe I'll send you. You can have an ensemble, some kind of a.
Sure, sir. Sure. Yeah. Thank you very much for your response. And maybe IMDA data also they are suggesting. Indra Rani madam.
Yeah, we can use that.
So we can use that, but I don't know within this 20 minutes or half an hour scale how much it can meet. Yeah. Let us see, sir. Yeah.
You have to make some certain bridging of the observation and model.
Yes, sir. Thanks for the floor, Rup Kumar sir. Dhanyawad.
Thank you very much. I see no more requests for floor. I think it's very interesting talk and very interesting discussion.
I have one question. Can I ask?
Yes. Yes, go ahead.
Can you hear me?
Yes, I can hear you.
Okay. I am R.C. Bhatia, and my question is, yes?
Sir, I'm listening, sir. Yes, sir.
My question is about the trends in the frequency of the western disturbances. Sir, you have done many papers on WDs, and you are quite active even now, I understand. My question was about, have you found any trend in the frequency of western disturbances, say during winter season or during post-monsoon season? Because the paper that you referred in your talk was from a recent Mahotsav paper by a IMD scientist working at Srinagar, and he has found a decreasing trend during March and maybe during October, November also. So did you also find similar trend in your work?
Sir, yes, sir. This is paper by Mukhtar Ahmad, Bappa Das, Sonam Lotus, and Mahbub Ali. Yes. And before that, Naresh Kumar also did for Central Himalaya, sir. So WD trend with my finding, as far as WD's definition is concerned, or WD precipitation is concerned, it is decreasing. And in case during DJF, I have shown one figure, it is getting less number of WDs with the intensity. But only problem is with the model, when people are trying to define with different track, different pressure, different. So in model, that's what I said, that observation analysis is not done for WD trend actually. Models, you can choose any indices to determine the model. Yes, I agree with that also. But in actual, what observation says, that needs to be done like these two paper in Mahotsav, while your this and one is Naresh. They have done for WD over these two. At least we have a Western and Central Himalayan region WD. But simultaneously, I also found that WD is shifting towards February. Precipitation is shifting towards February, not in December. So that's what I yet to analyze, why it is moving towards February. So December is having less precipitation, it's moving January, February.
Yeah, because there's a decreasing trend. As this year we saw during 2022, there were very small number of WDs.
WDs, yes.
That in turn affects the temperature over North India.
Yes,
this
sir.
year we had experienced very warm temperature during March. So this was attributed to small number of Western disturbances.
Yes, sir. I've shown one schematic plot in my talk, sir. WD is moving, taking elevation higher up because warming, and then WD is moving from Pir Panjal. It is not interacting the cascading mountain range. It is arriving directly to Karakoram also now. Because of the isotope analysis, we could realize. And another important thing, what we are finding, there is a lot of amount of non-WD precipitation happening. So we do not know from where it is coming from. Non-WD precipitation. In suppose you have 90 days. In those 90 days, WD is roughly 60 days. Rest of this 30 days precipitation is non-WD precipitation. That's what we have analyzing that, sir.
Is it maybe local convection or local orographic effect?
I do not know the precipitation mechanism, but yes, we could establish there is a non-WD precipitation. It is some kind of a shear trough is coming, col is getting formed, and because of this col, there is certain kind of moisture incursion is coming from Bay of Bengal, because that water is from Bay of Bengal. That's what we found from isotope analysis. It is not Mediterranean water when we do their isotopic analysis. So that's what we found, but mechanism we have not yet fully understood. We are trying.
Thank you. I think we have far exceeded our time, and that shows the interest that you have created, Professor Dimri. And once again, I thank you very much for agreeing to give this talk in the Azadi Mahotsav series. And on behalf of IMS, I once again thank you very much for your effort and also sparing your time for this talk. Thank you. Thank you, sir, for attending this and enjoying that.